Okay, semua boleh dengar suara saya?
Boleh.
Okay, Alhamdulillah. Okay, so untuk this is actually week 4. Okay, we are in the week 4. So we will continue our lessons on the force. Okay, so let me display the slide first. Okay, so basically these are the things that we're gonna learn in week 4. So this basically we are on the chapter 4. Right now we are on the chapter 4. Okay. Alright, so basically just do some recap on what we have learned. We have already learned about the Newton's first law, second law, third law, and of course these are the things, the free body diagram, the most important things when we deal, which is the free body diagram, how we're going to sketch the free body diagram. Okay, so the examples of the free body diagram, okay, and examples of this, okay, about how the F equals to MA will take place. Okay, for examples, okay, we only have we always have F equals to MA. Let me do. Okay, F equals to MA, but in terms of F itself, is always always comes with the submission of F equals to MA. Okay, because the submission means hasil tambah. Submission means hasil tambah. That means we need to add every forces that can involve in force. Okay, for example, we should consider every forces in x-axis, and if we are dealing with the y-axis, we also need to include it y-axis together. Okay, so in this case we have learned these things, right? Okay, the examples of horses pulling a barge, okay, where we can apply the concepts of vector here, which means we can apply the components of vectors. Okay, these are the components of vectors, and now at this point we have a magnitude, and this one we have a directions. Okay, so when we deal with F equals to MA, okay, we can establish this force. And of course, when it comes to the Newton's third law, okay, it says that every force that acts on an object, okay, there is a reaction force acting. So when there's a force, so there will be a reaction force acting on a different object that will be equal in magnitude and opposite in directions. Okay, so this is the examples of the action and reaction pairs. Okay, for example, if you are pushing the refrigerator, so there will be some forces. Okay? There will be a force that acts, okay, with the same magnitude. Which you can see, this is the F and this is the negative F, but acts in the opposite directions, of course. Okay, right, so these are some examples in terms of when push comes to shove. Okay, so when you have two boxes, okay, attached to each other, and you try to pull, you try to push, you try to give a force, only on one part of the boxes. Okay, So you can consider that as an external force. This should be the external force, where we will have an action-reaction force. This should be the Newton's third law will take place, where if there is a force, so there will be some reaction to that force that acts on the different position, okay, on the different magnitude and direction. The same magnitude, but the equals in magnitude, but in the opposite in directions. So therefore, we can reduce it to F1 and F2 because there must be some forces acting between box number 1 and box number 2 due to how it's attached. Okay, because box number 1 definitely will give some forces to the box number 2, and of course box number 2 will give some reaction to that force, that will be some equal in the magnitudes and but different in directions. Okay, and then this external force will add to the free body diagram, and in the free body diagram we can see we'll have some F1, okay, F2, and of course this one is the external force. Okay, and these are the things that we have. And number one is they want to find what is the acceleration of the boxes. Okay. So our job is to find that summation of fx equals to ma, which means the forces uh, uh, along the x-axis that equivalent to ma. So that what you mean by f equals to ma. So in the f equals to ma, we can see that there are a lot of forces involved. We can have external force, we have F1 and we have F2. So we can predict that, right? So the net between the forces, the boxes will be the horizontal or the external force is equivalent to 20 Newton. Okay, 20 Newton here. That means F definitely equals to 20 Newton. Okay, so F equals to 20 Newton. So as already stated. And how about the mass involved? So obviously, when it comes to the two things or two boxes involved in one particular situations, so we need to add because it moved together. Okay, we need to add M1. This is M1 and this is M2. Mass of number 1 and mass of the box number 2. So we should add all together to get it 15 kilogram. And 20 divided by 15 kilogram, we can see that we can have 1.33 meter per second square as its acceleration. Okay, so when it comes to the acceleration, 1.33 meter per second square. And then the next question will ask you about what is the force of contact between the boxes. Okay, when it comes to the word force of contact, that means they want to know the exact force that box number 1 gives to box number 2 or vice versa, which means force comes from the box number 2 to the box number 1. Okay, so because in from force of box number 2, okay, it still get you the same value as a force from box number 1. So that's why we can easily get it. All right. So for this part, find the net horizontal force acting on box 2. Okay, acting on box 2. Okay, because it doesn't influence by the external force. Okay, it doesn't influence by the external force. Therefore, we need, because it isolated from the external force. Okay, you can see here, this is box number 1 and this is box number 2. Okay, M1 and M2. There will be at M1 there is some external force. Okay, we don't want to calculate the force between the boxes by using the external force, right? But we need to know what happened here, right? So in this case, okay, we can use M2. Okay, they can use M2, which means M2 is the 1.33 accelerations of both boxes is 1.33 and times with 5, so you can get 6.67 Newton. Okay. Okay, and this is about Jack and Jill. Okay, we have already discussed it about Jack and Jill, how we're gonna break all the forces involved. Okay, we have F1, we have F2, we have W. Okay, and then when we do the free body diagram, remember free body diagram, okay, we need to do it on the just one simple situation, one simple body, one simple body, and then we need to attach every forces that involve. And then of course F1 and F2, if you look carefully, it comes with the angle. Okay, F1 and F2 comes with the angle. Therefore, we need to do some components of F1 and F2. Okay, how about W? Yes, W also have components, but on our belief that W is always equivalent to weight. Weight is always directly straight downward. Okay, so therefore W will be in the axis of Y. Okay, so in this case, without any hesitation, W doesn't have a x-axis component. Okay, W is always y component because it will be straight downward. It will be based on straight downward because due to the gravity. Because W is always equals to mg. Okay, will depends on the gravitational acceleration, right? So that's therefore W is always be in y axis only, not in the x axis, right? So therefore we still have to do components of vectors here. Okay, we need to do some components of vectors, right? We need to do a resolve, okay, which means f1x, f2x. Okay, look at fwx, wx0. Okay, they need to in the real case you don't have to put wx equals to 0 because we all must know that wx is always 0. Okay, so we don't have to put it here. Okay, they put it here just to make sure that you understand, okay, that wx will always be 0. Okay, how about the F1y? So this is F1y, F2y, and WY. Look here with the value of negative 12.8 Newton. Okay, negative 12.8 Newton, and then you add everything up, and then you get the acceleration to become 1.2 meter per second square. In this case, we considering okay, acceleration in y-axis because Jack and Jill is lifting, okay, lifting, okay, mengangkat ke atas, lifting the pin. Okay, it's not going to be an x-axis motion. Yeah, because Jack and Jill lifting the pin, so that means the acceleration is going to be only in y-axis. Okay, only in y-axis. Okay, these are some speed of the sled. Okay, you can have a force. So we need to do some. We know that the direction is going that way. Okay, this is the acceleration going to the x-axis. So we need to do some force. Okay, we need to remember this is the original one. F equals to ma. So submission of F to be on the precise fx equals to ma. Okay, do we need to put the fx at all time? No. Okay, at least you okay, you should determine. Okay, maybe because of you don't want to get confused between fx and fy, then you can put fx or fy. All right, so fx equals to ma, fy equals to I don't know, in this case fy equals to 0. Okay, because when we deal with something related to force, make sure you always comes to when we deal the problem, make sure you will have fx equals to ma, summation of fy equals to ma. Okay, in this case the slab is moving, moving on the surface of ice. Okay, the smooth surface of ice, that means the smooth mean, okay, it doesn't include friction, no friction. Okay, no friction. So therefore, okay, we don't have to consider a friction. Okay, but fx, so that means the acceleration of the sled is only happen in the x-axis. Okay, it's only happen in the x-axis, but in y-axis there will be no movement of acceleration. Okay, try to imagine that the sled is moving along the surface of ice. That means it just move on the x-axis. Okay, the sled doesn't a fly. Okay, dia tidak terapung naik ke atas ke terbenam ke bawah ke. Okay, so it just happen. The motion right now is only happen in x-axis. Therefore, at y-axis we can consider that acceleration is 0 at this point. So that's why we can say that summation of fy equals to 0. If there are if we need to include anything from y-axis. So everything when it move around, you need to know. Okay, either it's going to be MA or it's going to be 0. All right, or maybe it's going to be both. For example, the slab is moving like this. Okay, if this is some surface, try to imagine this is the slab, and the slab is moving this way. Okay, so meaning that there will be some y-axis component and also x-axis component. Then everything will become MA. Okay, so in the case of Jack and Jill, simple. Jack and Jill, summation of fx will be 0. Summation of fy will be equals to MA. So these are the things that we need to establish first. Okay, because these are the core of getting to get into the problems or situations. Okay. All right. So now we move to weight. Okay. So let's continue to weight. The weight of an object on Earth's surface is the gravitational force exerted on it by Earth. Okay. The weight of an object on the Earth's surface is the gravitational force exerted on it by Earth. So W here, okay, excuse for this wrong this one. It should be W equals to mg. Believe it or not, W is actually part of force. It's just the name that we need to establish it as weight, berat, W. So we can use W, but it actually comes from F equals to ma, because F is part of the weight. Weight is part of the force. Okay, M is always M, and acceleration now become gravitational acceleration. So therefore, weight is equivalent is actually F equals to ma, but in the y directions. Okay, in the y axis. So and of course, when we talk about weight, the directions of weight is always going to be downward, straight downward. It should be straight downward. Okay, you can look here by any means. Okay, the acceleration or the weight, the W is always to be. If happens you come to the problem of the incline problem, W will always be straight downwards. Okay, apart from the situations. Okay, maybe you will attach some things in the on the wall. Let's say this is your wall, so the weight will always be here. Okay, when you be given some problems, you must remember two things: weight and normal force. Okay, and also some external force. So in this case, when it comes to the normal force, okay, it must be on the surface of the ground. Okay, the object the object that have been put on the ground, okay, on the ground level, should have a normal force. Okay, now we go to normal force afterwards. All right, so let's look at some example here. A fire alarm goes off and a 19.7 kilogram fireman slides 3 meters down a pole to the ground floor, right? Suppose the fireman starts from rest, slides with constant acceleration. Okay, remember this is constant acceleration, so we can use various equations that we have learned in the previous chapter and reach the ground floor in 1.2 seconds. Okay, what was the upward force F exerted by the pole on the fireman? So we can assume that if the fireman try to slide, okay, sliding down from the pole, okay, so we can measure the weight. Obviously we can measure the weight, but in this question they want to know the upward force exerted by the pole on the fireman. That means maybe due to some friction. Okay, obviously there will be some a little bit frictions in this situation. because this is due to this F. Okay, some external force. All right. If there is no friction involved, then the fireman will slide down without any hesitation. Okay, so maybe if the fireman wants to slow the process of sliding down the pole, okay, the pole is quite high. Okay, for your information, and then if you try to sliding down with this constant acceleration, that means you're gonna have some impact, okay, at the ground floor. So he needs some protection for his safety when he's trying to slide it down, and of course they want to apply some upward force. Okay, so in this case we have to know what is the upward force. So for example, for instance, we need to measure first the acceleration. Okay, because this is not a free fall. Okay, not a free falling. Why is not a free fall? Because it's due to the situation where, okay, the the fireman now, okay, use his weight. Okay, it's not falls under the gravitational acceleration. Okay, because that is why this is not a free fall. Okay, so we need to measure the acceleration. Although it is stated in the question that the acceleration is constant. Okay, the acceleration is constant doesn't mean it doesn't have acceleration. Of course, there will be some acceleration when the fireman move. Okay, and of course, in this case, we can use, right. So now we should focus on this part. Okay, why? This is actually from this equation that delta y equals to v naught yt plus half ayt squared. Okay, and remember, a delta y is actually delta y is y minus y naught. Y minus y naught. Then we bring y naught to this part. It comes like this. Okay, and of course v naught yt. Okay, initial velocity. There will be no initial velocity in this case because it starts from rest. Starts from rest. That means no initial velocity. So therefore, v naught y will be 0. So that's why it's only left here y naught plus half ay t. Okay. So we can say that this is your y naught. This is your y. Okay. So y is at 0. Y naught is at 3. So therefore, we can put here y is 0. Y naught is 3. Okay, 3 meters. Plus with half negative 9.8. Negative 9.8 t square. Okay. Alright. So the time is 1.2 seconds to reach to the ground floor. We can put here 1.2. Okay, replace it with 1.2. You can try it on your own, right? To get it negative 4.2 meter per second square. Okay. Alright, so that is only acceleration. Now it comes to the force, because the real objective here is to find force. Okay, so force Fy equals to F minus mg. How do we know that F equals to mg? All right, so by look at these situations. So in this case, the only free body diagram that we can draw is just here. Okay, it's just between F and W. There are no other forces involved. So it's just the F and W. So when you try to write down Fy, okay, now I'm using Y because it's happened in Y axis. So equivalent to MA, because there will be some acceleration involved in Y. So we can write down as, okay, F minus W equivalent to MA. Okay, or you can write down as W, because the situation now is going this way, which means W will reach the ground first. Okay, in my term, in my term, okay, if you want to know which forces should be put in front, okay, so I'm using a situation, I'm using some analogy like this. Between F and W, okay, which forces will reach the ground first? If you look carefully, F is if at the top bottom at the top part, and at the bottom part is W. So definitely W will reach the ground first. Then we put W. W equals to W minus F equals to MA. If you want to write down the F minus W, we can also put it as F minus W, but you need to consider that A will be positive. Okay, A will be negative because it is against the acceleration. So in this case, W minus F equivalent to MA. Then what is F? F is, we want to know about F. So just leave that part. Okay, so W is mg. Mg minus F equals to MA. Okay. In the suggested and in the suggested operations here, okay, let me emphasize more on this part. Okay, in this suggestion, okay, it give you F minus mg. Okay, they are using F minus mg, which means F minus W. F minus mg. So when F minus mg equivalent to ma, okay, equivalent to ma. So F minus mg equals to, okay, and F equivalent to ma plus mg. So it's stated like a plus g. Okay, a plus g. All right. So what happened is, when the f itself, okay, when we try to deal with, say if I'm using this part, so mg minus f equals to ma, okay, which means we want to add it, so we bring this here, and this one become here, so mg minus ma equivalent to f. So f equivalent to uh, m times g minus a. But remember, the acceleration, our acceleration is negative. Okay, so in my part, m 9.8 minus with minus 4.2. But in this case, if you are using the same concepts, but using f minus mg, then m will become a negative 4.2. Okay, negative 4.2 plus with 9.8. Okay, it's just the same value, right? And then, of course, it will give you 540 Newton. Okay. Okay. So, in this case, we just need to considering, okay, which should be minus. It's either mg minus f or f minus mg. That will depends on the situation where is the directions of the acceleration. Is the acceleration is going downwards. So w will follow, or mg will follow the directions of acceleration. So that's why I'm considering. Okay, right? All right. So let's go to the apparent weight. Okay. So when elevator moving downwards, okay, when the elevator moving downward comes to rest, we feel heavier. Why? Okay. So when we are using elevator, okay, lift, for our instance, lift. So we should know about apparent weight. Apparent weight, the other names of apparent weight is just the terms of normal force. A normal force is actually apparent weight. Why? Because in this case, we can see that the apparent weight direction is here. Okay, this is the directions of apparent weight. It's just the name of it's just the name, but the apparent weight situation, when you know, okay, the human body will have mass. Okay, we have mass, and due to some gravitational acceleration, we will have weight. Mg is always going to be downwards, and the apparent weight will be the force that is always perpendicular to the surface. Okay, force that perpendicular to surface. So that's why I'm saying now, okay, apparent weight is just like a normal force. It's the equivalent to normal force. What is normal force? Capital N. Okay, I have shown you about the normal force. How it's going to work about the normal force. Every forces that acts, okay, perpendicular to the surface is called a normal force. In this case of the moving elevator, we can say that the normal force is the apparent weight, because it will keep changing. Your weight is always fixed because due to your mass and your gravity, except if you did the experiment in on the moon or on the other planets that have a different gravitational acceleration. But when you do when you try to wake yourself, okay, in every corner of the world or of the earth, so we are using G, except for maybe there will be some situation that that place doesn't have a gravity of 9.8, for example. Okay, but if you are using a gravity of 9.8 or maybe 10 in your own terms, okay, we're still using the same weight. The weight is will be fixed, but the normal force will keep changing due to the situation. Why? Okay, so let's focus on this part. Okay, when elevator is going upward, okay, so that means the acceleration is going upward. Okay, so elevator going upward, acceleration will going upward. So what happened is, then, okay, look at the summation of F. Okay, summation of Fy is equivalent to, or we should write down as this one. Summation of Fy equals to Ma, which means what's in the y? So n minus mg equals to ma. So what happened is n equals to ma plus mg, and m equals to a plus g. Okay, that is when the elevator going up. What happened to the elevator when the elevator going down? So it also happens due to summation of Fy equals to ma. Okay, right now acceleration is going downwards. Okay, you look at it carefully. W minus n equals to ma. Okay, and n equals to W minus ma. What is W? Mg minus ma. Okay, and then m will be g minus a. Okay, there are two different things. Okay, the same happen when we try to solve this problem, but due to the acceleration. Okay, acceleration going positive or negative or gravitational is always 9.8. Okay, so therefore we can say that that's why when elevator moving downwards, or we feel heavier, but that is not the due to our not due to our weight. It just happened to because of the apparent weight. Okay, so in this case, if you look carefully, the apparent weight, okay, the apparent weight, the NA or the WA or the N or WA will be, when we move, uh, it will be greater than our value. Okay, greater than the mg, greater than the ma. So due to this part, due to the explanation here. Okay, because of the moving acceleration is going downwards or upwards. Okay, so don't focus on the situation, just focus on the how you're gonna tackle the problems, how you're gonna put the right equations, how you're gonna put maybe they want to put it w minus n minus w. Can you put n minus w also? Yes, you can, but you need to put a negative. For example, okay, let me do some example here. If you want to use, for example, in the second situations, if you want to use when the elevator is going down, then eh, you want to use n at the in front. Okay, so you can use n minus w, but remember n minus w meaning n is going upwards, w is going downwards. So what happened to the acceleration when the elevator is going downwards? So definitely, okay, we will see that negative. We should put a negative MA. Then we should put a negative NA to the equations, because of right now the one that should reach the ground first is W. So W now, okay, the acceleration now doesn't follow W. So we need to put a negative at the negative MA. So that is the difference between how you're gonna write down, because that's why I'm using the analogy like this. Okay, you want to know which should be put in front of the equations, you should see, okay, or you should look at the situation. What is the forces that can reach the ground first? If the acceleration is moving downwards, if the acceleration is going upwards, or what is the force that lead the situation for when the elevator is going upwards, so N will reach the top first. Okay, what happens to the when the elevator is going downwards, acceleration also downwards, then W will reach the ground first. So W in this case, if you want to write down, okay, because you always have a situation of N, okay, atas selalu kena tolak dengan bawah, right? So you need to know, you can put the N minus W, but you need to put a negative here. Okay, try to finish this up. So N minus W equals to negative MA. N will equals to negative MA plus MG, because it should be here. And what happened is, okay, MG minus MA. So N will be MG tolak. Okay. So there you can see the same answer you will get. It's just like you need to put the right terms. You need to put the right annotations, so you can have a correct value. So this is the normal force. Okay, the normal force is the force exerted by a surface of an object. Okay, the normal force is always perpendicular to the surface. Okay, always perpendicular. In this case, so you can see the W is going downward. The W is going downwards, and N. Okay, we can put it here. Just put it at the free body diagram. Just put it. Okay, the same the parallel line with the weight. Okay, but as you can see, okay, for example, if there's some inclined situation, W is always downwards, and where is the N? N should be here. Okay, 90 degrees, 90 degrees with the surface. So N will depend on the surface. If you put it or you hang it on the wall, okay, so W is always downwards, and N should be here. Of course, there will be another forces involved, maybe due to friction or what. But you need to know the concepts of normal force is always perpendicular to the surface. Okay, this is one good example on how you're gonna break the free body diagram. Okay, for example, you have a briefcase like this. Okay, so this is your W. You write down W. You write down N. Look at how I'm writing N, and you can see here some external force involved. So you cannot put it here. Okay, just put it here. Just put it on the same line, on the same point. So this should be the angle. Okay, so in this case, this is the external force. So in your terms, you can put it here as F cos theta, F sine theta. Okay, F cos theta, F sine theta. So that means if you are considering, okay, if you are trying to write down the equations, now look at how it going to be. Okay, for example, summation of fx equals to ma. Okay, so that means if you look carefully, then just only one forces involved in x-axis, which means F cos theta equivalent to ME. But in y, you can see here summation of Fy equals to MA. Maybe if the briefcase is sliding around along the x-axis, so you can have 0 at acceleration y. Okay, but in this case we just put ma, so fy. So what is in the fy? We can have f. We look at how I'm going to write f sine theta plus with n minus with w equivalent to ma, or that depends lah. If there is no acceleration, then you can put 0. So you need to know every forces in this part. Okay, so this is fx, this is fy. So try to imagine these things. If you are dealing with the problem with the forces, make sure, okay, you jot down. You need to know which part is the, okay, maybe it's due to x-axis, or maybe it's due to y-axis. So you need to know, you need to differentiate between the x and y-axis. Okay, and need to know the forces involved in x-axis and y-axis. In this case, at your level, we are considering x and only x and y-axis. Okay, we don't do simultaneously except for some situations, but that is very rare. Okay, so there are some applications on the Newton's law. Okay, so do you have any questions as for now?
Sir,
Yes.
so if the n is negative, may I consider it as negative MA also?
Pardon?
Kalau macam n,
Mm-hmm.
negative n, it will
Negative,
be equals to negative MA also, can?
negative m. Macam mana tu?
Negative n, the
Negative m.
normal, yes.
Okay. Pardon. Okay.
Kalau n negative, MA
Mm-hmm.
pun negatif.
Kalau n negatif, a pun negatif. Macam tu ke? Soalan kamu?
MA yang
MA. Okay.
ah, ah.
Tak, dia tak boleh cakap macam tu. Actually, n negatif bermaksud macam tadilah. Maksud dia maybe acceleration dia going ke bawah. Tapi dia sebenarnya macam mana cara kita nak tulis. How we gonna write down. Okay. Kalau kita suka dengan negatif. Kalau saya, okay, saya cakap terus terang. Kalau saya, okay, my practice is always like this. Okay. I'm always writing down. I hate negative value. Senang cerita, I hate negative value. I always want the positive one because I always want that my value should be MA at all time. Okay, jadi saya akan consider apa-apa situation. For example, kalau normal force saya jadi negatif. Normal force saya jadi negatif is because of due to dia moving ke bawah. Okay, moving ke bawah. Maksudnya dia tengah bergerak ke bawah. Okay, jadi W tolak dengan N. Sama dengan MA. Tapi kalau saya nak pakai N tolak W juga, then saya kena letak negatif MA. Ini cerita dia kalau ada, katalah ada satu objek turun ke bawah. Bukan dengan free fall ya, turun ke bawah. Okay. So maksud dia macam case tadi lah, elevator kan. Elevator turun ke bawah. Tak apa, saya akan display dulu. Pemahaman ya. Okay. Elevator. This one eh. So, kalau kita tengok elevator, yang satu contoh yang paling baik. Right? It's a very good example when it comes down to the how you gonna write down. Ini is just a matter of writing down the normal force and the acceleration. You can see here, okay, the elevator is going downwards. Okay, going downwards. Okay. My practice is always like this. Okay. Elevator is going downwards. Ini contoh dia tunjuk ni acceleration going upwards. Kita tak nak. Okay, acceleration going ke bawah. So acceleration kalau ikutkan, okay, yang ni tukarlah jadi N. Dia takut confuse. Okay, I pada duit. Dia saja je nak gunakan, nak buat kita confuse kan. Alright. The acceleration is going downwards. So bila acceleration going downwards, that means motions of the elevator is always going downwards too. Dia akan ke bawah jugalah. That's why acceleration ke bawah. Okay. So my practice is always like this. Siapa yang akan jatuh ke bawah dulu? Siapa yang akan sampai ke ground floor? So saya letakkan W lah sebab N duduk kat belah atas. N lambat sikit. N lambat sikit, W sampai dulu. Kalau sampai ke atas, N sampai dulu. W sampai kemudian. Macam itulah. Bahasa senang dia. So saya akan letak, kalau dia gerak ke bawah, saya akan letak W di depan tolak dengan N sama dengan MA. Tapi kalau kamu tak suka dengan W kat depan tu, dia adalah juga kan, ada orang yang tak sukalah sangat. Tak best lah W kat depan kan. Okey. Dia selalu ingat yang benda yang sebelah atas mesti tolak sebelah bawah. Benda yang sebelah kanan mesti tolak sebelah kiri. Dia selalu berpegang dengan benda tu. Okey, tak apa. Okay, no problem. You can put N minus W, but remember to put it as negative MA. Why? Because you are opposing the acceleration right now. Okay, tadi acceleration turun ke bawah, tapi kalau awak consider N yang duduk di depan, then awak kena letak negatif. Itu cerita dia. Sebab awak sedang melawan arah acceleration. F awak ni, yang duduk di depan ni, awak anggap dia positif ni, sedang melawan arah acceleration. That's how it means. Boleh?
Okay, boleh.
Okay, good. Okay, any questions? Okay. So untuk ada applications ni, okay, the attention elevator pulley. Okay. So tomorrow awak akan ada break. Okay. Untuk break esok, saya ada kelas on Wednesday. So saya akan record dan saya akan letakkan dalam Google Classroom. So the rest of this explanation about applications of Newton's law will be presented in the Google Classroom. Boleh faham ya? For your class, make sure awak dah faham applications of Newton's law ni dengan tengok sendiri. Kalau tak faham juga, kita akan buat di dalam kelas tutorial ataupun itu je lah. Sebab ini semua ialah application. Macam mana kita nak apply dia dalam kehidupan. Tension, incline, benda-benda ni. Ni semua awak dah belajar kan? Tapi kalau tak faham, awak boleh mula-mula tengok dulu saya punya recording video dengan kelas lain tu. Saya akan letakkan dalam Google Classroom this week also. Saya akan letakkan juga insyaAllah. Okay. Sebab esok awak cuti. Kalau awak tak cuti esok, saya akan record dengan kelas awak. Sebab nanti saya takut awak tertinggal. Kalau saya minggu depan baru nak masuk force ni, akan tertinggal. Takut kelas awak makin jauh, makin lama makin jauh. Okay. So, you need to study the pre-recorded videos. Boleh tengok dalam pre-recorded videos yang saya dah letakkan dalam Google Classroom, or you can find the link to my recording videos. Recording of explanation about the applications of Newton's law. Yang ni lah. Okay, saya akan letakkan juga. Okay, so nanti boleh tengok. Okay, there will be some cases involving forces. Okay, for example, we can have this one. Mula-mula bila kita tengok situation ni, apa yang kita kena fikir? Kita kena fikir submission of fx jadi apa, submission of fy jadi apa. Itu dulu. So bayangkan kalau dua-dua tidak bergerak, inilah situation traffic light. Awak ada nampak traffic light gerak kiri kanan atas bawah? Tak ada. Okay, so submission of fx will be 0, fy will be 0. Simple lah. Jadi kita faham dulu situation ini, yang physics dia kat sini. Yang bawah-bawah ni semua ni dah maths ni. Ni maths semua ni. Physics dekat sini. Macam mana you nak point out that fx equals to 0, fy equals to y? Dia asal dia f equals to ma. But due to the situation where this thing is a static, so acceleration become 0. So that's why dia jadi kosong. Kan? Right? So slab. Ini incline motion. Incline campur dengan ada satu tension dekat sini. Dekat sini kita akan belajar dua benda. Belajar mengenai incline. Maybe kita tak nak go through yang ni dulu. Kita go incline dulu. Kan? Tak sempat dah masa. Nanti kamu akan tengok. What happened during the incline session? Kan? Apa yang nak kena di-consider? Apa equation apa yang nak di-consider? And then lastly, about the pulley. Ni kita belajar pasal pulley. Ada orang tak suka mengenai pulley ni. But it's very good to understand the whole concepts of pulley. The whole concepts of where is the directions of acceleration. Going upward, what happened to this part? Going downward, what happened to this part? Sebab tu equation dia sangat-sangat memain peranan. Okay, that's why I'm always telling you, in order to understand the forces, make sure you do understand the concepts of the directions of acceleration. Acceleration going upward, siapa akan jadi duduk atas, siapa akan duduk bawah. Physics bila dah faham yang tu, you datanglah soalan apa-apa pun, then you have no problems. InsyaAllah. Okay. And then lastly about the forces of frictions. Okay, so nanti kita akan tengok. Okay, please, okay, watch my pre-recorded, watch the pre-recorded videos, and please watch my recorded videos. Okay, after Wednesday, insyaAllah saya akan upload dalam Google Classroom, then you can see, or you can watch. Tolong tengok dengan baik. Okay, and then for untuk okay, untuk kefahaman bagi application, the rest of the chapter, applications of the forces. But if you find a difficulty of understanding about this part, tolong point out which part during masa kita, bila kita bincang tutorial ke, ataupun masa kelas, the next class on next Monday ke. So please point out. Okay. So I think I'll stop here. Ada soalan lagi ya? Have questions? Okay. Alright, so I'll see you. InsyaAllah kita jumpa malam tutorial sekejap lagi. Okay, so I think I'll stop here. Okay, I'll stop here first. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Thank you, sir.